Okay, so today we're going to be talking about more dividing fractions. And we're going to be using these bar models similar to what we used yesterday, right? So the bar model can also be used to divide fractions by other, of course, fractions, okay? So let's look at what we have. It says Mr. Felix modeled the problem 7/8 divided by 2/8 in the bar model below. Complete the model below to show how many groups Mr. Felix will make. So that's fine. What I'm going to do is partition my bottom fraction bar into eighths as well. And of course, I'm going to label them all as 1/8. Cool. Now, there is a rule that we must know and we must follow in order to actually divide these fractions, okay? And this particular rule is called KCF. Keep, change, flip. Okay, we're going to keep the first fraction. We're going to change our division sign to a multiplication sign, and we're going to flip the second fraction, also known as the reciprocal. So we're going to get 7/8. We're going to change our division to multiplication. We're flipping 2/8 to 8/2. Now, before we actually multiply straight across, we do have to start looking at what's called common factors, okay? These are numbers that can be multiplied into multiple numbers. What I mean by that is we're going to look for common factors diagonally. So there is no common factor between 7 and 2, but there is a common factor between our 8 and 8. That common factor is 8. 8 can go into itself once. 8 can go into itself once. Then when we multiply straight across, we end up with 7 times 1, which is 7, over 1 times 2, which is 2. Now, we can find this one of two ways. We can decompose. Okay, if I know that 2 can fit evenly into 7 3 times, then I know that I have 2 over 2, which is 1 whole, 2 over 2, which is 1 whole, 2 over 2, which is 1 whole, and what's left will be that half. That's 2, 4, 6, 7 halves. 1, 2, 3. This is all 3 and 1/2. You can also just divide. Obviously, that's going to be a great way as well. So we have 7 divided by 2. 2 goes into 7 3 times. 3 times 2 is 6. 7 minus 6 is 1. In this particular case, you add a decimal up top, a 0, and you bring it down. 2 will go into 10 5 times. Ergo, we still have 3.5. It's just written as a decimal instead of a fraction. Either way is fine. I'm just going to write it as a fraction here. Not a big deal. But that's how we're going to solve using these pictorial models. All right, sliding on up. Okay, now it says use the model to show how many times 1/2 will fit into 5/6, or basically 5/6 divided by 1/2. So because my first fraction tells me I have sixths, I'm going to partition my top bar into sixths. So I'm going to split it in half, put 1, 2, 1, 2. On the inside, I'm going to write 1/6, 1/6, 1/6, 1/6, 1/6, and of course 1/6. Now, the difference here is that I'm actually going to shade in a little bit. Now I have 6/6 over here, but my first fraction says I only have 5/6. So that's all I'm going to be shading in is that 5/6. just like that. All right, now. Cool. They want me to figure out how many 5/6 will fit in 1/2. So these are going to be labeled as 1/2, and those are going to be labeled as 1/2. Now, we're going to go ahead and solve and figure out what exactly our answer is going to be, and it'll correlate directly to our two fraction bars, okay? So I'm going to keep my 5/6. I'm going to change my division symbol to a multiplication symbol, and I'm going to flip my 1/2 to 2/1. Now again, I want to look for what's called common factors. I see a common factor shared between 2 and 6, and that common factor is 2. 2 can go into itself once. 2 can go into 6 3 times. And we multiply straight across. So now I have 5/3, which again, you can decompose. 5/3, I can pull 3/3 from that, which is 1/2. What's left is 2/3. So my answer is 1 2/3. Now, when we shade, our shading has to match. So 3/6 can fit into 1/2. That'll give us what we need there. That represents our 1/2. But only 1/2 will actually shade in. All right? And it'll look something like that. So we have our 1 and our 2/3 right there. Okay. Now on the bottom, it's actually super easy. All they want you to do is find the reciprocal. Now the reciprocal is a fancy word for flipping your fractions. All right, that's actually what we call it, the reciprocal. So the reciprocal to 16/21 is just 21/16. And we don't have to solve, we're just finding our reciprocal. Reciprocal to 8/11 is 11/8. Reciprocal to 3/1 is 1/3. And the reciprocal for 1/5 is 5/1. Next page. Okay, here we're going to continue to practice. Okay, so remember, at the top we're writing KCF. Keep, change, flip. Okay, so we're going to keep our first fraction. We're going to change our division sign to a multiplication sign. We're going to flip 3/5 to 5/3. Now, there are no common factors between any of these numbers. So 1 times 5 is 5, and 4 times 3 is 12. Therefore, our answer is 5/12. Moving on to number 6. We're going to keep that first fraction. We're going to change our sign. We're going to flip our reciprocal. Okay? Now here we actually do see some common factors. 4 and 8 both share the factor of 4. 4 can go into itself once. 4 can go into 8 twice. And then we cross, or we multiply straight across. When we do that, 7 times 1 is 7/2. So here we can just divide. You can decompose it if you'd like as well. Here we're going to divide. 2 goes into 7 3 times. That's going to be a 6, 1, decimal, 0, 0. 2 goes into 10 5 times. Our answer here is 3 1/2. Now, when it comes to number 7, there's a little trick that I learned. and it's great. I like it a lot. Let's see how we can utilize it best, okay? So when it comes to mixed numbers, in order to divide a mixed number, we must turn it into an improper fraction. That means our numerator is going to be larger than our denominator, but our denominator stays the same. And the trick I've used for this is to walk around Texas. So as we do that, we see 6 times 2, which is 12, plus 5, which is 17. 17 over 6. I'm going to change my division sign to a multiplication sign, and I'm going to flip my 2/3 to 3 over 2. But again, I'm always looking for common factors. If I can simplify early, I will. 3 can go into itself once, and 3 can go into 6 twice. We multiply straight across, and we end up with 17 over 2. Now, 17 divided by 2. Basically, 2 can go into 17 evenly 8 times. That's going to be 16. 17 minus 16 is 1, and it stays the same over our denominator. Sorry. All right, 17 divided by 2. Is that right? 2, 8, 16, 1, 0. Yeah, I'm right. Cool. Sorry, I had to double check. So our answer for this one is 8 1/2. When we get to number 8, we're going to keep our first fraction. That's 3 over 10. We're going to change our division sign to a multiplication sign. And we're going to flip our 3/5 to 5 over 3. Now again, I do see common factors. 3 goes into itself once. 3 goes into itself once. 5 goes into itself once. 5 goes into 10 twice. When we multiply straight across, we should end up with 1 times 1 is 1, and 2 times 1 is 2. Therefore, this answer is 1/2. Let's keep going. All right. So we're going to rewrite these problems. This is going to be 5/12. I'm going to change my sign. I'm going to flip my reciprocal, and then I'm good to go there. Here I'm going to walk around Texas. 4 times 2 is 8. 8 plus 3 is 11. 11 over our original denominator, which is 4. I'm going to walk around Texas. 7 times 1 is 7. Plus 4 is 11. What we should have is 11 over 7. But I need to change my sign and flip my fraction. So instead of 11 over 7, it's 7 over 11. If I set this one up, I have to walk around Texas. 3 times 5 is 15, plus 1 is 16. This will be 16 over 3. We keep that. Change to multiplication and flip our reciprocal. Now, when we start showing the work, we're looking for common factors first, if we could find them. I don't see any common factors there, so I'm going to multiply straight across, and that's going to give me 25 over 24. Now again, I can decompose that as 24 over 24, which is the same thing as 1 whole. What's left is 1 over 24. Therefore, my answer is 1 1/24. Here, there are no shared common factors between 7 and 4, but 11 can go into itself once. 11 can go into itself once, and we multiply straight across. We end up with 7 over 4, which again you can decompose as 4 over 4 and 3 over 4. 4 over 4 is equal to 1. Therefore, our answer is 1 3/4. For this third one, there are no common factors between 3 and 5, but 2 and 16 share the common factor of 2. 2 can go into itself once. 2 can go into 16 8 times. When we multiply straight across. Now, we'll end up getting 40 over 3. All right. Here we'll have to divide. So we'll get 40 divided by 3. 3 goes into 4 once. 1 times 3 is 3. 4 minus 3 is 1. We bring down our 0. Now we have 10. 3 can go into 10 3 times. 3 times 3 is 9. That'll be 1. Add a decimal. Add a 0. You're going to start to see it repeat. Now, when it starts to repeat, it's not necessarily the end of the world. It just means that we have to understand what these repeating fractions mean. 0.33, especially continuing, is the same thing as 1/3. So we have 13 and 1/3. And that is our answer there. All right. Let's move on to this next part. So they said circle the name of any student who wrote a division problem with a quotient between 1 and 3. Quotient means the answer you get after you've multiplied, and they want that answer to be between the numbers 1 and 3. So any type of fractional number should go in between that. So here, I'll walk around Texas to get our 5 over 2. I'm going to change my sign, but I'm going to write my other fraction down here since I have the space. I'm going to walk around Texas. 3 times 2 is 6, plus 1 should give me 7/3, but I got to flip it, so it's really 3/7. Multiply straight across. You'll get 15 over 14, which of course we can decompose as 14 over 14, which is equal to 1, with 1 remaining. So our answer here is 1 1/14. 1 1/14 is between 1 and 3, so I can circle Keena's name. When I start working on Milton, I only have to walk around Texas once, so that's what I'll do. I'll walk around Texas. 5 times 3 is 15. Oh wait, plus 1 is 16 over 5. I'm going to change my division sign to multiplication. I'm going to flip my 2/7 to 7 over 2. Now in this particular case, I do see a common factor. 2 goes into itself once. 2 goes into 16 8 times. When we multiply straight across, we should end up with 56 over 5. Well, here we're going to use just like a little bit common sense, okay? 5 times what number will give me close to 56? 5 times 11. 5 times 11 will give you 55. Our denominator stays the same, and 56 minus 55 is 1. Now, is 11 and 1/5 between 1 and 3? No. So I'm not going to circle it. All right, let's talk about Lily real quick, and then we're done. Lily, We're going to have to walk around Texas here too. That's okay. We're going to walk around Texas. 4 times 1 is 4 plus 3 is 7 over 4. We're going to change division to multiplication. We're going to flip 2/3 to 3 over 2. There are no common factors diagonally. We will multiply. We will get 21 over 8. Again, I know 8 can fit into 21 evenly twice. Our denominator stays the same. 2 times 8 is 16. 21 minus 16 is 5. 2 and 5/8 is also between 1 and 3, and that's why we can circle both Kina and Lily. I hope this helped, y'all.